in this video will apply Kramer's rule and use determinants to solve linear equations. We'll start from the two-equation system. So x1, x2, these are unknowns. A and B, those are constants. If we look at the left-hand side of this equation, we can write that down as this form. If we call this matrix as A and apply what we learned from the previous video of determinant, the determinant is simply equals to A11 multiplied by A22 minus the product of these two, A12 multiplied by A21. We'll use it later. What the Kramer's rule tells us is the solution of x1. It can be written down as the determinant of b1, then a12, b2, a22, divided by the determinant of matrix A. So the D here is the same as the D here. For x2, the solution is the determinant of the matrix A11, B1, A21, B2, divided by D. Again, the D is the same as the D. So by knowing the determinants of these matrices, we can solve x1 and x2. I want to say a couple of things about the numerator in these solutions. If we are looking for the solution for x1, the entries corresponding to x1 are a11 and a21. What we do in Kramer's rule is we replace these two coefficients by b1 and b2. Similarly, when solving x2, what we are doing here is to replace the coefficients a12 and a22 by b1 and b2, while the rest of the matrix remains the same. Let's look at one example with numbers. So we have these two equations. So 4x1 plus 3x2 is equal to 12. Then 2x1 plus 5x2 is equal to minus 8. And it asks you to solve x1 and x2. So the first thing we can look at is the determinant of the matrix A. So matrix A can be written down as 4, 3, 2, 5. And the determinant D that A is simply 4 multiplied by 5 minus 3 multiplied by 2. That is equal to 20 minus 6 gives you 14. Apply the Kramer's rule. So x1 will be equal to b1 and b2 if we write that vertically first. These are 12 and minus 8. Then a12 and a22, these are 3 and 5. Then divided by D. If you solve the matrix of the numerator, you will get 84 divided by D, which is 14. That gives you 6. For x2, apply the same technique. So a11 and a21, again, let's write that in columns. These are 4 and 2. Then b1, b2, that's 12 and minus 8 divided by D. Then the determinant of the numerator, I will skip the calculation, that gives you minus 56 divided by 14. And for x2, it equals to minus 4. That's how you obtain the solutions for x1 and x2. Please do not forget, you can also use the Gauss elimination method to solve these two equations. and you will get the same answer. Moving to the three equation systems. Let's look at how to use the Kramer's rule to get the solutions for x1, x2, and x3. Write down the three linear equations. Then the solutions for x1 is equal to d1 over d. D is the determinant of the matrix on the left. So the matrix composes of only A's. Then x2 is equal to d2 over d, and x3 is equal to d3 over d. Then what are d1, d2, and d3s? Using what we just learned from the two equation systems, we mentioned when looking at x1, the new matrix we construct is to replace the coefficients by b's. So d1 will equal to the determinant of the new matrix b1, b2, b3, while the rest will remain the same. The same approach applies to d2. In d2, these coefficients will be replaced by b. For d3, it's exactly the same approach. Then these coefficients will be replaced by b, and we're getting the determinants of this matrix. For the three equation systems, I will not use numbers. How to apply the Kramer's rule to solve these linear systems is pretty straightforward. In the next video, we'll change gears a little bit and introduce two new concepts: identity matrix and inverse matrix.